In number 1, it says the number of pockets in the clothes worn by 7 students to school yesterday was 4, 1, 3, 4, 2, 2, and 5. Today, those 7 students each had 3 pockets on their clothes. A asks us to draw one dot plot for the number of pockets that each student wore yesterday and then another one for today. Make sure we use the same scale. So we're going to start at 1 and go all the way up to 5 so we can include all of that data. Now, the first one was a 4. Then we had 1, 3, 4 again, 2, 2, and 5. But today, they all wore 3. So the 7 students wore 3 pockets. There should be 7 dots because each one represents 1 student. Now for B, it says, that's teeny tiny. For B, it says, for each distribution, find the mean number of pockets worn by the 7 students and show the mean on the dot plot using a balancing triangle symbol. Well, this one, the mean is going to be 3, because if you add up those 3's and divide by 7, you're going to get back to the thing you started with. On this one, we need to add the number of each point and divide by 7. 1 plus 2 is 3. 2 plus 3 is 5. 4 plus 4 is 8. And if we keep adding, we'll get 8 here. And 8 and 5 is 13. And 8 and 13 gives us a total of 21. 21 divided by 7 is also 3. So up here on our dot plot, we need to draw a triangle around 3 as well. Now part C. C says, for which distribution is the mean number of pockets a better indicator of what is typical, and explain why. So looking at these dot plots, where or which one does the mean look more like the typical value? So because today's dot plot has all the values on 3, 3 is a better indicator of the typical value. The mean on the one from yesterday is also 3, but the points are more spread out, so it's not as good of an indication. The mean for today's is a better indicator because there is less or no variability. None is definitely less than some. So, the mean for today's is a better indicator than it would be for yesterday's. Number 2 says the number of minutes, rounded to the nearest minute, it took to run a certain route was recorded for each of the 5 students. The results of the data are this. The number of minutes rounded to the nearest minute it took for 5 students to run a different route was also recorded, and those are the data listed after. Part A says to draw a dot plot of the times for the two routes. Be sure that the same scale is used on both. Our smallest number in all of these is 6, and our biggest is 19. So we need to draw our number lines from 6 to 19. This is going to be route 1, and this one will be route 2. Now that our number lines are drawn, we need to put the dots on there. So make sure you put a dot for each number listed, each time listed. And then do the same thing for the other one. Then B says, do the dot plots have the same mean? So we're going to add up all those values for each route. And then for route 2, we have and then once we're done, we want to divide by how many there are. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So add those all up. For this one, you get 60. And for this one, you get 60 as well. Then 60 divided by 5 is 12. So both have a mean of 12. And draw the triangle. Part C asks us, in which distribution is the mean a better indicator of the typical amount of time taken to run the route? And explain. If we look at the route 1 and route 2 dot plots, which points are closer to the mean? Which one has less variability? The mean for route 1 is a better indicator because there is less variability. They are less spread out. The times for the second route are more varied or more spread out than the first. So the mean for the first route is a better indicator, a more precise typical value.